soon. An expensive request is maybe if I try to save this file to a disk, or if I try to send this file over the network. Okay, so if I answer the cheap request quickly, then the user is more satisfied. Okay, my expectation is satisfied. Okay, cheap and expensive actually don't always correspond to reality. Sometimes what I think is cheap might be very expensive CPU wise for the operating system. So these are the considerations for the interactive system. So they are very different. They are batch systems. They talk about throughput, turnaround time, and CPU utilization. Okay. Interactive systems, we don't talk about CPU utilization. Okay. Have you ever seen any cell phone operating system trying to maximize the CPU usage? We don't maximize the CPU usage on the cell phone, right? Why? Because if we try to maximize the CPU usage, what would happen? I would eat up all of my battery in half a second, right? So we don't do that. So, but in these kind of situations, batch systems, I try to use the CPU most of the time because CPUs are very expensive. Okay, I don't want my CPU to sit idle while there are jobs waiting to be processed. But in interactive systems, you don't see any CPU utilization here. You see what you see? You see the response time and the user expectations. I might lower my CPU utilization just to meet response time and the user expectation criteria. Because if my CPU utilization is low, right? If my CPU utilization low, my response time would be better, right? So for the interactive systems, higher CPU utilization is not a good thing. It's a bad thing most of the time. Okay. In the real-time systems, my criteria is all different. Okay. I need to meet deadlines. Okay. I need to meet deadlines. Okay. Avoid losing data. These are important things. Predictability. Users must know when the request will finish. They have to be done by a given amount. Okay. And they require a careful engineering to match the priorities to actual competition times and available resources, because they are not for interaction, they are not for batch processing. They are there to check some kind of a device. For example, the video players, right? They are soft real-time systems, video players. If I don't show 50 frames per second, and every third second I am skipping some frames, or frames are not shown properly, then my system is not working very well. So I am not meeting deadlines. My system is not predictable. It's not a very good real-time system. I am not talking about the responsiveness. I am not talking about the CPU utilization. We are talking about the meeting deadlines and predictability. So each of these batch systems, interactive real-time systems, they have their own scheduling priorities, scheduling criteria. Okay. So what is the time now? So I think I am done for today. Tomorrow, if there are, let me hear one or two questions before I stop. Bir iki tane soru sorun, ondan sonra ben ara vereceğim. 10 dakika değil, bir gün ara vereceğim. Bir gün, tam bir gün mü? 26 saat ara vereceğiz. Bir tane soru sorun, devam edelim. Soru sorular bırakmayacağım. Scheduling ile ilgili. Ödevde scheduling'de ne yapacağınız kafanıza yatıyor mu? Anladınız mı ödevi? Scheduling ile ilgili. Çünkü bu ödevi, o scheduling'i yapacağınız aklınıza tutarak yaparsanız eğer daha rahat edersiniz herhalde. Yani bundan bir sonraki adım hafızaya birden fazla programın yüklenmesi ve onların arasında hani bir tane CPU tick rutini var ya, CPU tick her 5 adımda bir interrupt yapacak. Her 5 adımda bir proses switch edeceksiniz. Tamam mı? Ona göre yapın. Soru sormuyorsunuz hala. Geçen dönem bu ders alan var mıydı? Aranızda vardır herhalde. Kaç kişi var mı? Bayağı yavaş gidiyor değil mi geçen döneme göre? Doğru mu?
Evet.
Evet.
Şimdi bu ikinci chapter'ın sonuna geliyorum. Bu hafta inşallah bitiririm bu ikinci chapter bu schedule'inden sonra. Üçüncü chapter'a başlayacağım gibi. Bayağı yer hızla gidiyorum gibi ama bilmiyorum, çok hızlanamadım. Çok da hızlanmak istemiyorum açıkçası. Yani tıkı tıkı üzerinden geçerim ama biraz otursun istiyorum. Evet.
In Linux, we have license for processes, and some daemon processes has maximum license, so they are the most prioritized process. But sometimes they just stop and give their turn for other processes. Our operating system does this, and why? I mean, they are the most prioritized processes, and they should be running all time.
Well, if a single process runs all the time, rest of the operating system just starves, right? They don't do anything. So even if you have, you have the highest priority doesn't mean that you can use the CPU all the time yourself. That means that if the scheduler makes a decision, it gives you the highest priority. Next time the interrupt happens, you have to switch. Somebody else has to take the control. Okay? So, since Linux or Windows, they are all preemptive based operating systems, when the timer occurs, you have to switch to some other process, and you choose some other process with the highest priority. And you cannot switch to back to yourself. You have to switch, right? So you cannot, unless you disable all the interrupts and you say that I'm going to run forever and when I am done I will let you know. Unless you do that, which is a very, very rare case, you have to switch. When you switch to some other process, next time it is time to switch again, you can come back to your process and do it again because you have the highest priority. Highest priority doesn't mean that you run all the time and don't let any other process to run, take the CPU time. That would be very bad for your operators because it would freeze all the mouse movements, all the interactivity, and everything. Did I answer your question? Kind of. So highest priority doesn't mean that you finish your job first and then all the rest will continue after that. That would be a batch processing. Highest priority means that when it's time to switch, when it's time to schedule a process, which process should I choose? So, and you make this decision many, many times a second. Okay, so we will continue tomorrow.